Geometry is all about perspective. And what I mean by perspective is it's all about how you look at it. It's all about what you are looking at. It's all about where you are in a triangle and what parts are surrounding it. So trig is a very, very detailed, specific topic. If you understand the basics of how the setups work and how what I like to keep referring back to as the perspective of everything else falls into place rather quickly, because the algebra part of trig is really nothing more than just pressing a couple buttons on the calculator, at most a one-step equation. Okay? At most winds up being one-step equations. And then we are able to utilize that to solve all the rest of the parts of triangles. So here's the deal. So far in geometry, what we've looked at, we've had right triangles, so we've had our Pythagorean theorem, then we've had 45, 45, 90, 30, 60, 90s. Now, the trig stuff that we're going to look at over the course of the next few weeks also deal with right triangles, but it's going to deal more when you don't have a special right triangle. So you're still going to be able to solve for all the missing parts by pressing some buttons. And again, it's about perspective. So here's what happens. What I want you guys to think of here is a generic right triangle. Plain old boring right triangle. And when you have a right triangle,
I cannot tell if it's a right triangle. Oh my God.
Thanks, Whiskey, for reminding me. You know, I'm old and I'm forgetful.
Oh, that is true. Yeah, that is.
Hey. So, in a right triangle, you're always going to know two things, no matter what. You will always know where the right angle is, and what's the side length called opposite the right angle all the time?
Hypotenuse.
Hypotenuse. So inside a right triangle, no matter what, of all 6 parts that are going to be in a right triangle, you will always know 2 of them, where the location of 2 of them are, where the right angle is, and then where the hypotenuse is. So basically, you know 1/3 of the information, 2 out of 6. So what happens then is a matter of what else you are given. What else are you placed with? Here's what I mean. If I sit here as an angle, and a lot of times you will see angles with the variable, they'll put a little degree symbol in it. Sometimes they might use what's called theta. Theta is more of a proper way to show an angle. It's the algebra 2 method of showing it, so sometimes I might draw that symbol. That just means an angle, instead of using, how I've always done, like angle, blah, 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 things like that. So it's all kind of the same deal. But if I'm at this value of x, I'm always, always, always looking at the side opposite me. If I'm at this angle, this is the side I'm looking at. It's called my opposite. And I just abbreviate it with that. Okay? The side opposite you is what you are always looking at. All right? That wall is opposite me because I'm looking at it. Okay? Now, just for argument's sake, if I was up here, now what am I looking at? Another opposite. Again, notice how it's a change in perspective. It depends on where you are. Your opposite could move. We'll come back to that later. So, right now, if I'm sitting at this lower angle, I know the side that I'm looking at is, you need to draw this picture and write this down. This is extraordinarily important. Don't just sit there. If I'm sitting there and looking at that, I'm at that angle spot. I'm looking at the side opposite me. The side that's then next to me, we don't just call it the next to side. There's a more specific name for it.
The nexus?
No, it's called the adjacent. So we have hypotenuse, opposite, and adjacent. And I just abbreviate it with adjacent with ADJ, not adjective. Okay.
Which
Because-
modifies a number of pronoun.
That was a great description. Thank you very much. I'll be here all week.
The week's almost over.
Right, exactly. So, what happens here is when you place yourself in a triangle at one of the angles, your hypotenuse never moves. The side opposite you and the adjacent can switch depending upon which of the other two angles you are located. Okay? So if I'm placed here, I'm always looking at my opposite. Next to me is always my adjacent. If I'm up here, I'll call this angle Y, we said a second ago. Now this would be my, if I'm up here at Y, I'm looking at my opposite, this is my, so it can flip-flop depending upon your perspective, okay? So, let me show you an example. Bless you. I want to label my parts.
Okay, you're 90 degree angle is strong.
Okay, hold on a second here. So if I do this, when I start this style out, as we get going into this trig stuff, my suggestion to you guys is always circle the angle that you are given. Now, we may or may not know what that angle measure is, but
It's 90.
Whiskey, when we deal with trig, Whiskey, we don't worry about the 90-degree angle, because when you work with trig functions on 90 degrees, there's a reason why we don't press the button for it. And it goes back again to the idea of what happens in Algebra 2. In Algebra 2, you have the unit circle.
Oh, good, sir.
Thank you. Up here is an ordered pair. That ordered pair is at 1 and 0. The reason that it does that is because at 90 degrees, actually, I'm sorry, that's, yeah, so sorry, it's here. At 90 degrees, we have a 1. Am I backwards? No.
I don't know.
Exactly.
You're the teacher.
No.
I don't even know this.
Yeah, I'm sorry. Yeah. So
Do something about algebra 2.
if you go the other way,
So just tune out first.
That's pretty
cool.
Like that.
That's not cool.
Yeah.
Let's just focus on.
Fascinates my mind.
I always see this once.
what happens, I know. What happens is at 90 degrees, you have different values for your sines and cosines. You have a cosine value of 1 and a sine value of 0. You have a tangent value that's undefined because when you take 1 divided by 0, you can't divide by 0. This is the 90-degree value is a pi over 2 radian measure. Pi over 2 radian measure is what we call a quadrantal angle. Quadrantal angles don't work within our normal right triangle. Hey, you asked. I thought I'd tell you. All right, anyway, back to this.
Yeah.
So, if I circle my x, what I want you guys to do then is, what's this side? Opposite. What's this side?
No, that's the
And what's this side?
opposite.
Don't listen.
Stop it, Liz.
That's what I want to work on. That's what I want to work on. Because the quicker we're able to identify parts within a triangle, when we start worrying about what in the world these buttons on our calculator stand for, once we worry about perspective, about labeling, where this stuff comes into play is a piece of cake. But we need to know this. Psst, that's not your calculator. Where's your calculator?
You're good at whispering.
Huh? Oh, okay. Make sure you get that one back, all right? Excuse me. All right, straight on. Where did I have it? Here. Let's look at this. We're not solving anything, are we? I'm not solving it. All I want to do is label. I'm not solving anything yet. We're not there yet. Okay? We're not there yet. So, all I want to be able to do as of right now, guys, maybe in the next 10 minutes or so, we'll start to explain which trig function goes with what. But for right now, I just want to do a couple of quick examples about how you locate the parts within the triangle. Okay? So if I start again with my angle, here I'm given this angle of 29 degrees. Please make it a point to circle it. When you circle it, you will see that we draw these arrows. And we make an arrow looking at it. Remember when we did that with the 30/60s and the 45s, when I wrote out that model? 45 looks at the X, 30 looks at, because that's the side opposite it. That was the whole idea, because I was getting you guys accustomed to angles look at sides opposite them. So if you're at the angle, you're always looking opposite you to your side. So I'm looking at my side opposite. So X is in opposite. 16 is a hypotenuse. Okay. So what we're getting towards here is trigonometry is nothing more than ratios of sides via their angles in a right triangle. That stuff, the ratios don't change. Each one of these three different, what we call trig functions, has their own ratio to the sides. And it's about the perspective. Stop reading your book and write notes down. It's very important that you do this stuff, okay? I appreciate the reading, okay?
This is the foundation, you guys, for this unit. It's going to be tough if you don't grasp this introductory concept.
You're drawing a lot of triangles.
You do. There's a lot of them. And in time, it becomes easier because you'll see there's a reason why we do this extra work up front. All right, there is a reason. It's just, I know it's painstaking. There's a lot of redundancy to some of this. Because some of you guys are like, okay, yeah, I get it. I know what my opposite is. I know what my adjacent is. I understand where my hypotenuse will always be located. But the better you get at picking those out quicker, how much easier it'll become later on, okay? So again, if I start here at my 37, what is that 37 looking at?
19.
It's looking at the 19, which means it's opposite, which makes the 14 the adjacent. Bless you. Bless you. Do we have a number value for our hypotenuse? No. Could we figure out a number value for the hypotenuse? How? Yeah, I can do a squared plus b squared equals c squared. Now, the reason why I'm saying that is because sometimes you can use trig, and sometimes you can use Pythagorean theorem, depending upon what is being asked of you to find and what you need to find. Okay? And eventually you will see that either method works. you get the same answer. But we'll talk about that in a second. Yes, sir.
Be 23.6.
Okay, I'm not ready to get to that part yet about how to verify that with the trig, but yes, if you square it and go through there, it's got to be more than the 19, so it sounds feasible. Excuse me. So here's where this goes to then. When we're looking at these three figures, what happens is they have ratios of sides. So the sine, they shorten it, it's actually spelled S-I-N-E. It's actually spelled, is it with a G or is it a J?
No, it's G. Because the E following the G makes it sound like a J.
That's why I abbreviate.
It's a box rule.
I'm hooked on that.
You're also hooked on that.
I don't mean hooked on that.
Oh.
All right.
Yeah.
245. 250, sorry, 250. So you have sine, cosine, and tangent. Now, we abbreviate them because nobody likes to write more letters than they need to. Okay. So let's look at what's called the sine of an angle. The sine of some angle. I'm going to use this value of x. When you are in a triangle, the sine of some angle is always going to be equal to the side opposite divided by the hypotenuse. So the sine of some angle in degrees is your opposite over hypotenuse. Okay. So it looks weird right now. It looks really, really, really weird. Remember, it all backs down to opposite, hypotenuse, adjacent. So the sine of some angle is the opposite over hypotenuse. The cosine, I'll just go through all three of them real quick. The cosine of some angle is the adjacent over the hypotenuse. So right there, if you just go back and think about how I was talking about perspective, about what values do you know, what side lengths do you know? If you know a side opposite you and you have a hypotenuse, you use sine. If you have a hypotenuse and the side next to you, you use cosine. It's all about what you know and what you can use. So your cosine is that adjacent value over the hypotenuse. Excuse me. Bless you. And then the last one is tangent. The tangent doesn't utilize the hypotenuse. The tangent uses, bless you, the tangent uses the opposite and the adjacent. Let me slide this up here. So your tangent is when you have just the opposite and the adjacent. If you know those two. And it's by knowing what and how to label, by knowing how to label your triangles, it is very easy to distinguish between which values you're going to use. Okay? Juan, put away your phone and the other phone, please. That's the idea of being able to know what you are looking at. Okay. Can you write down in more of the sequential order so that way you can find it all in one spot, so here to here to here, so if you put it all together, it'll be easier to find later on. What's the top one? Who's the sign? What's that? It's the opposite over a hypotenuse. So it's sorry. Remember when you're at an angle. Remember how we always said that your angle looks at the side opposite you. That's where it came from. So when you think about how, remember we talked. Well, you weren't in here, but remember how we always wrote these things out. That the 45 looked at the x. It looked at the x. It looked at the x root 2. The reason why I was using these arrows the other day was to get you on the idea of angles look at sides opposite. That's why I do that. I was preparing you for the next lesson. It's a trick. You'll get there, okay? So go back to this. If I go back to this, and I look at this example, I have a right angle. I have a right triangle. Let me rephrase that. I have the right triangle. I have a value of 42 degrees for an angle. And what is the given side length that we have? The given side length is the 14. That 14 is always is being played by the role of what? A hypotenuse. So when I start to label this problem, always start by circling the angle. Draw your arrow. What is that side called?
Opposite.
It's your opposite. What is the 14 called?
Hypotenuse.
Hypotenuse. So go through your list. Which of the three work with opposite and hypotenuse? Sine. Pronounce. It's not a 9-inch nail song. It's sine. Okay? So that means that the sine of this angle, the sine of 42, would equal x over 14.
What? I just got that?
Yes, sir. Now, I'm not worried about pressing buttons here. I don't care about pressing buttons. I just want to be able to set this up. I want to set that up. Yes, ma'am? That would be wrong. Because the sine is always the opposite over the hypotenuse. Okay? That's how that would have to work. In Algebra 2, there is a different method of what you said. It's called the reciprocal function. The reciprocal, because you know how you can reciprocal anything? If you reciprocal sine, you get cosecant. So the reciprocal of sine would be cosecant, which means it would be. She asked the question. All right, I'll stop. Hey, Madison, you may forget the last 15 seconds. Good work. Yeah, Whiskey.
I need help.
Hold on, Whiskey.
Just not noticing. You've been out. You've been on the floor. This one would be 10.
Yeah.
Whiskey,
What?
are you in the dunk contest?
No.
Oh, why not? Good ball.
Sorry.
I need help.
What?
This.
Well, just draw a picture. Start with that. Start with drawing the picture.
Oh, actually, I think I got it.
All right, hold on. What is the first thing you think I'm going to tell you guys to make sure you do?
Circle.
31.
Circle the angle. And then what?
Draw
Draw your arrow. X is being played by the role of the opposite.
Excuse me.
17 is being played in the role of the
Adjacent.
adjacent. So go through your trig functions. Yes, ma'am? Yeah, do you mind?
It's gonna be the very bottom.
So which of these three has just opposites and adjacents in them?
The very bottom.
The bottom one, the tangent. So that means then that the tangent of some angle is your opposite over the or adjacent. Well, what angle am I working with? I'm working with 31. So the tangent of 31 is, well, what's opposite?
X over 17.
What this is getting you guys set up to be able to do in a little while, I honestly don't think I'm gonna even bother with it today, is that it's going to force you guys to set up a one-step equation. That's all this stuff does. But it's a matter of, can you get to this from the picture? Yes, ma'am? Yes. Unless we don't know the angle, and we'll do that next week. Good. It could be. It could. Yes. Yep, exactly. And that's the whole point of being able to circle, label, and go. Because if you do that,
Mr. Moore,
yeah,
what's our homework?
getting there. What's that? All right, take a second, guys. Take a second or two and write out the ratios for these four. Look here. All right, let's take a look real quick. Circle your angle. X is a opposite. 20 is the, what trig function you're going to use with opposite hypotenuse?
Sine.
Sine. So that means the sine of 24 is your x over 20. Okay? Everybody got that?
Yes.
Okay. Let's just go right below here on 7. Circle the 19. 12 is your opposite. X is your hypotenuse. What trig function is opposite hypotenuse?
Sine.
Sine again. So the sine of 19 is, 12 over x. That's all. We're not solving anything yet. Don't worry about it. Okay?
Don't worry.
Go to the number 6. Circle the 40. 17 is an opposite. Would you mind? X is the hypotenuse. Well, it's kind of redundant here. What one are we using?
Sine.
It's not a sin. It's not 9-inch nails.
Wait, how do we? Hey, Mr. Murphy, why is it a sign when we're not really signing anything?
Whiskey, stop asking.
And then the last one.
Sign again?
Careful.
No,
Oh, no, wait, no,
it's the.
Start at the 41. X is the,
How we doing?
12 is the, which is using. Very good.
Wow.
I mean, if it just stays like this.
How do you know if the sign?
It really does stay like this. It's just a matter of the sequence that you have to press buttons in the calculator. And that's where it can get kind of messy if you're not careful. But if we get this down, the rest, because you write this out, guys, if you write this stuff out, you're going to be less likely to screw up in the calculator. Because if you just try to do this in the calculator, you're going to screw up. That's why I don't use it yet. So this one was, like you were saying, was tangent 41. Okay. Now, all I want you guys to do tonight, or over the weekend, I should say,
Is rest.
yes, no.
Oh, I don't know. They're gonna give us a lot of chapters to read over the weekend. Just because we have 2 extra days. Man, I'm not gonna read. They give us like 5 or 6 chapters. She'll be right back, Jimmy. What? She'll be right there.
No, I don't want you guys pressing any buttons. I don't want anything worked out. All right? So guys, it's getting. Ladies and gentlemen, this is being. You guys not get one? Oh, thank you. Now, as this comes forward to you, you will see that we've already done the first 8. What I would like you to do, didn't we, I gave you some things. Bless you.
Miss Murphy is not.
What I want, all I want you guys to do, all I want you to do, well, is this. When you get on, this is how every problem should go. I start on number 9. What I'm going to have you guys do is circle your angle, label your parts. What trig function do you use? Opposite, adjacent, and then write it down. That's all I want you guys to do. I don't want you to press any, you don't need to use a calculator, you don't need to use anything.
Nice.
All I want you to do is that. And it, obviously there's another, 10 or so on the back side of it here, but as you can see, it shouldn't take more than 10 minutes, right? It shouldn't take very long. But, suggestion, big suggestion, make sure you have a generic picture and make sure you have your 3 functions written down on this sheet. Okay? Draw a generic picture, write down your 3 generic functions, and then go from there. Come Monday, we will talk about how we can take these values, which you guys are going to set up basically a whole bunch of examples, and how you press buttons in the calculator in the correct sequence to get the right answers. Now, right off the bat here, if you read the instructions, it says round the nearest tenth. I will never ask you round to a tenth. I will always say 100. I just forgot that was there. So pay no attention to any rounding stuff right now. We're not doing that. Okay? All you need to do, we've already done those in our notes really. So start on 9 and finish. Okay? So what you're doing is you're starting on 9 and finishing her out. You've already done the other ones in your notes. Yes, sir.
Hold on. Whiskey.
I don't want you to do that. I don't, because you're doing, you're going to have rounding error by doing what you just did. I don't want you to do any of that. Okay? Yeah, don't press any buttons. Okay? Excuse me.